Greetings to you all. Now let us do the what to call the quadratic number pattern. This is a number pattern that has a constant second difference. Okay, this type of number pattern was treated in grade 11, so it is also assessed in grade 12. So let us now have an example of a quadratic number pattern. Now let us consider the pattern 2, 5, 10, 17, 26, etc. So here we subtract the first term from the second term. We say 5 minus 2. 5 minus 2 is 3. 10 minus 5 is 5. 17 minus 10 is 7. 26 minus 17 gives us 9. So this is the first difference. This is the first difference. So how do we get the second difference? We say 5 minus 3 we get 2. 7 minus 5 we get 2. 9 minus 7 we also get 2. So this is the second difference, and we can see that the second difference is constant. Okay, good. Now the general term formula allows you to determine any specific term of a quadratic number pattern. Okay, and is given by, that is, Tn equals to an squared plus bn plus c. Okay, now let us come. Now the next question, the question that we have that arises, is to how we will be able to determine the general term of any given quadratic number pattern. So we say, suppose that the general term of a particular quadratic number pattern is given by this. Okay, so if we want to get, if this is the case, if we want to get term number one, that will be equal to, where we see n we put 1, that will be a into 1 squared plus b into 1 squared plus c. Okay, so this gives us 1 squared is 1 times a is a. 1 squared, sorry, we're not supposed to have the square there, because it's supposed to be just n. Okay, so 1 times b, that is what? That is b plus c. Now this is going to be our term number 1. Now let us come to t2. So for t2 we're going to have a 2 squared plus b into 2 plus c. Okay, it's not supposed to be squared, it's just n. So for t2 we're going to have 2 squared is what? It's 4. 4 times a, it's 4a plus what? Plus 2b plus what? Plus c. Okay, now let us now try to get term number 3. How do we get t3? We're gonna say a into 3 squared plus b into 3 plus c. This is going to be equal to 3 squared is 9. This is going to be 9a plus 3b plus c. Now let us try also to get term number 4. For term number 4, this is going to be equal to a into 4 squared plus b into 4 plus c. So this is going to be 16a plus 4b plus c. So now we've got what? We've got 4 terms. Okay, 4 terms. Term number 1 here, we have what? That will be a plus b plus c. Okay, and term number 2, that will be what? 4a plus 2b plus c. And term number 3, that will be 9a 9a plus 3b plus c. And term number 4, that will be 16a plus 4b plus c. Okay, let us do like this. Okay, now we want to get the first difference. Okay, for the first difference, now for a, we're gonna say 4a minus a, because we need to do it like this. Okay, what you call the first term, the second term minus the first term, we get that. The third term minus the second term, and we get that. Okay, now this is going to be 4a minus a. Here we're going to have what? We're going to have what to call, that will be 3a. Okay, 3a, and then that will be 2b minus b, because we say this term minus that will be 2b minus b. The answer is going to be b. Okay, the answer is going to be b. And when we say c minus c, the answer is 0. So you've got what? You've got 3b there. Okay, and we are also going to have what? For the what to call, we subtract the second term from the third term. So we're gonna say 9a minus 4a, that is going to be 5a. Okay, and then we have 3b minus 2b, the answer is b. Okay, c minus c is 0. Okay, so we are fine for this term, and we say what? We say the fourth term minus the third term, 16 minus 9, that is supposed to be 7, that will be 7a, and then 4b minus 3b, that will be b, and then c minus c is 0. Okay, so we have it like this. Okay, this is our first difference. Okay, this is our first difference. Now we need to get what? We need to get the second difference. So this is going to be 5a minus 3a. We are going to get what? We are going to get 2a. b minus b is 0, so just left with 2a. Okay, and then we say 7a minus 5a. This is going to be what? This is going to be 2a. b minus b is 0. So we can see now that the second difference is constant. Okay, now the second difference is constant at what? At 2a. Okay, the second difference is constant at what? At 2a. So from here we can now safely say, okay, going back from to this, what to call, to this quadratic number pattern, to this quadratic number pattern, we had what? We had we had 2, 5, 10, 17 and 26. Okay, we had that, and then we also had 3, 5, 7, 10, and here we had 2, we had 2, we had 2. So now we can safely say, okay, so this will be equal to the first term of the quadratic number pattern. So this 2 is going to be equal to, a plus b plus c. This number here is going to be equal to a plus b plus c, as we can see from what we had there. Okay, now this one is going to be equal to what? It's going to be equal to this one. It's going to be equal to 3a plus b. Okay, so this one 2 is going to be equal to what? is going to be equal to this one, which is what, which is 2a. 2a is equal to that. So from there we can be able to determine what, to determine the what to call the general term of what, the general term for a quadratic number pattern. So if we were to determine the general term of this number pattern, what would we get? So we're going to start here. We would say, okay, 2a is equal to 2, so we solve for a. So we divide both sides. This is going to be 2a equals to 2, divide by what, divide by 2, divide by 2, a, this cancels this, a is equal to 1, a is equal to 1. Okay, now since we know a, now we need to solve for what, for b. So we're going to say, okay, 3a, sorry for that, 3a plus b is equal to what, is equal to this, so it's equal to 3. But we now know that a is equal to 1. We say 3 into 1 plus b is equal to 3, and this is going to be what, this is going to be 3 plus b is equal to 3. You transpose 3, b equals to 3 minus 3, b equals to 0. Okay, good. Since we now know that b equals to 0, we come to this one, and then we say, we also know that a plus b plus c is equal to what, is equal to 2. We know what a is equal to 1 and b is equal to 0. We are looking for c. All this is equal to 2. So we transpose 1. C is going to be equal to 2 minus 1. Now c is going to be equal to 1. Okay. So now we come to our general term there, which is equal to what, Tn. So our Tn is going to be equal to, what is the value for a? The value for a is going to be 1n squared, 1n squared, plus, what is the value for b? B is 0, 0n, plus c. What is the value for c? C is 1. So our general term is going to be equal to n squared plus 1. Okay, so we need to first find a, b, and c. Okay, so we now know that how do we find that? We first need to find the first difference and the second difference, and 2a is going to be equal to the first value. We're going to be equal to the constant difference. 3a plus b is going to be equal to the first term of the first difference, and then ab plus c is going to be equal to the first term of the quadratic number pattern. Okay, good. Okay, now let us come to do example 1. Okay, example 1. Okay, now with example 1 they say, consider the following number pattern: 6, 17, 34, 57. Show that this is a quadratic number. This is a quadratic number pattern. Okay, so how can we show that? Now let me say this is going to be our solution. We're going to show them by showing them that it has what, it has a constant second difference. Now we have 6, 17, 34, 57. So we're gonna say, okay, 17 minus 6, that is 11. 34 minus 17, that is 17. And then you say 54 minus 34, that is 20. Okay, that is no 57, not 54. 57 minus 34, the answer is 23. Okay, now we're looking for this. I'm gonna say 17 minus 11, it's 6. And then we say 23 minus 17, the answer is what? Also the answer is still 6. Okay, so that is how we show them that this is what, this is a quadratic number pattern, because it has what, it has the second difference. B, write down the next two terms of the number 13. Okay, so how are we going to get that? Okay, we are gonna be using what we have here, because you know that we just have to add what? We just have to add 6 to get the next number here. Okay, so we're just going to say 23 plus 6 to get this one. This one has to be 29. Now we are going to add 29 from that 57 to get this number there. Okay, this is going to be 57 plus 29, so this is going to be 86. And then we know that we still have to add another 6 here. From 29 we add 6 to get this number, and we add this number to that 86. This is going to be 29 plus 6. This is going to be 35. Here we're going to have 35, and we say 85 plus 35, and then we get 120. So for us to get there, that will be what? 120. So the next two terms is going to be what? Is going to be 86 and 120. Okay, now here they say hence determine the nth term. The nth term is the general term as well as the hundredth term. Okay, good. So how do we get that? C, let me just divide our page into two, and let us try to find the general term. Okay, so we are going to say, okay, 2a is going to be equal to what? Is going to be equal to 6. Okay, 2a is equal to 6. We solve for a, we divide both sides by 2, this cancels that. A is equal to 3. Okay, right. We also know that, okay, here what is this equal to? From this equation we know that 3a plus b equals to that, so we're gonna say, okay, 3a plus b is equal to what? 11. But we just got a here. 3 into 3 plus b is equal to 11. So this is going to give us what? 9. And you say 9 plus b is equal to 11. We transpose 9. B is equal to 11 minus 9. B is equal to 2. Good. But also we know that this 6 is equal to what? A plus b plus c is equal to that. That will be 6. But we know what that is equal to 3. So this is going to be 3 plus 2, we just got b here, plus c is equal to 6. So this is going to be 5. Okay, this is going to be 5 plus c is equal to 6. C is going to be equal to 6 minus 5, which is equal to 1. C is equal to 1. So our general term Tn is equal to an squared plus bn plus c. Okay, so our Tn, which is the nth term, is going to be 3n squared plus b is 2, 2n, c is 1 plus 1. This is going to be our nth term. But we were also asked to determine as well as the 100th term. So how do we get the 100th term? So with the 100th term, where we see n, we substitute what? 100. So we're looking for term number 100. That will be 3 into 100 squared plus 2 into 100 plus, sorry for that c, this is supposed to be c equals to 1. This is supposed to be 1 there. c is equal to 1. So this is plus 1 there, and then you come with partial this in our calculator. 3 into 100 squared plus 2 into 100 plus 1. So this is going to be 30 tau 201. This will be term 100 from this quadratic number pattern. Okay, now let us now do D. We're asked to determine which term equals 162. Okay, now from there we know that we now have what? We now have what? The general term there. So our general term Tn, which is equal to 3n squared plus 2n plus 1. So when they say which term, they are actually looking for what? We are looking for n. Okay, we're looking for n, but we know the term is 162. So this is going to be 162 is equal to 3n squared plus 2n plus 1. Okay, so we write this in standard form by transposing this into this side of the equation. So we're going to have 0 is equal to 3n squared plus 2n plus 1 plus 1 minus 162. This is going to be 3n squared plus 2n minus 161. Okay, so we're looking for n. So for us not to confuse ourselves, let us take the easy route. That will be using the quadratic equation. When I say n is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. That will be equal to negative b is what? B is 2. 2 is there, plus or minus the square root of 2 squared minus 4 into a. A is 3, c minus 161. Okay, and we divide all this by 2 into a. A is how much? A is 3. Okay, so what are we going to have there? So we're going to have a negative 2 plus the square root of 2 squared minus 4 into 3 into negative 161 divided by 2 into 3. The answer is 7. N is equal to 7, or n is equal to, and we still have to also use a negative sign there. This is negative 23 over 3. So this one is invalid. Okay, we cannot have a term that is negative. So the correct one is this one. So that will be term number 7. That is equal to what? That is equal to 162. That is equal to 162. Okay, so we have another example that we can do, which is example 2. Now here we are told that 6, 15, x, 45 is a quadratic number pattern. Determine the value of x. So what we have to do, we just have to do this up until to the second quadratic, to the second difference. So we're gonna say 15 minus 6. 15 minus 6 is 9. We have 9 there, and you see the second what to call term there, that will be x minus 15, and the third one there is going to be 45 minus x. Okay, now for what? Now let us do for the second difference. For the second difference, we're going to say what to call x minus 15, right? X minus 15 minus what? Minus 9. Okay, it is this term minus that. Okay, so what do we get there? We're gonna get x minus 15 minus 9 minus 24. Okay, from there, and we're gonna say 45. We're gonna say 45 minus x minus this, minus x minus 15. So this term subtracts that one. So what do we get there? We're gonna get 45 minus 15, that will be 30. We're going to get 30 minus x, that will be minus 2x. Okay, so this is going to be what? This is going to be our second difference. This is the first difference. This is going to be what? This one is going to be our second difference. Okay, so but we know that the second difference has a constant. The second difference is constant. Okay, so meaning these two terms are equal. So we're going to say therefore x minus 24 is equal to 30 minus 2x. Okay, so I take this one to the other side and I'm transpose this one to this side. So you're going to have x plus 2x is equal to 30 plus 24. Now I have 3x. This one is going to be 54. Okay, 3x equals to 54. We divide both sides by 3. Divide by 3. This cancels that. X is going to be equal to 54 divided by 3. It's 18. So now we managed to get what? We managed to get the value of what? To get the value of x. X there. Okay. So good people, that will be the end of my lesson. I hope you enjoyed. Thank you.